Welcome back, everybody. This is going to be the final of two parts in my lecture series involving complicated inequalities. If you haven't seen the last video, please go and watch it now, as it's going to be important for this video. Because in this video, we're going to look at how to solve inequalities involving rational functions. Let's get started. What I mean by that are inequalities like this guy. X minus 4 over x plus 3 is greater than 0. It is tempting to multiply the x plus 3 to the other side, in which case we'll just lose it. But here's the problem, and this comes as a warning. We should not write x minus 4 greater than 0. Because the denominator still contributes to the sign of the left-hand side. So it is important to consider it here. How do I accommodate this warning? Well, I tackle these problems the same way I would do my polynomial inequalities, except that on my sign chart, I also want to include my vertical asymptotes. So I want my vertical asymptotes and my intercepts. Because as we saw in the previous series, that is where my rational functions might change sign. I might dramatically flip to the other side of the x-axis suddenly after crossing that vertical asymptote. So when I have a rational function, not only do I need to set it equal to 0 to find its x-intercepts, in this case, that will give me 4, but I also need to find my vertical asymptotes, which would be at -3. So on my sign chart, I need to have both 4 and -3. And these are the regions I need to test. So I'll test with -4, with 0, and with 5. Go ahead and pause the video here to see if you can finish filling out the sign chart on your own. I found that the solution set was -infinity to -3 and 4 to infinity. Feel free to pause the video here to check my work. Let's try one more. This one is a bit of a challenge. Go ahead and pause the video here to see if you can try it on your own, but if you need help, let it play a little longer. Ready for a hint? It might be easier to tackle this problem if we rewrite it as a problem we know how to do already. This one's a little tricky because I've got rationals on both sides. But just like when I have polynomials on both sides, I simply just subtracted everything over to one side and rewrote it that way. And that's what I did here. Except that subtracting two rational functions is a little bit more complicated because I need to find a common denominator. But after all of that work, I end up with -15 over x minus 2 times x plus 3 should be greater than 0. This is the same inequality. And this is one we've already seen how to do. Go ahead and pause the video here to see if you can finish it off on your own. I found that the solution set should be -3 to 2, including neither of them. Go ahead and pause the video here if you need to check over my work. In this video, we saw how to solve inequalities that involved rational functions. That's going to wrap it up for this series. I'll catch y'all in the next one.